Good morning, children. Sairam. Children, today I am starting with the next chapter, that is thermodynamics. Children, as the term suggests, thermo, what is the meaning of the word thermo? The word thermo means related to temperature. Dynamics means related to change. So, the word thermodynamics, in this chapter thermodynamics will be studying the effect of change of temperature on various systems. Now, in previous chapters, like in the previous states of matter, you've learned about some of the gas laws. You all know that chemical energy, it is stored in the molecules and released as heat. That means related to temperature. Whenever chemical reactions takes place, like when the fuels like methane, cooking gas or coal or any other thing is burnt in air, it produces heat. How is the heat produced? By the chemical reaction. Now, in many types of cells also, electrical energy is converted into chemical energy, or sometimes chemical energy is converted into electrical energy. There also the heat changes are accompanied. Now, we'll study about the different types of heat changes, temperature changes in this chapter. Now, first of all, we have to start with the system and the surrounding. What is the meaning of a system? See, in this chapter, I'll use the word system for that part of the universe which is under observation. Like for example, you all can see here a beaker is filled with some liquid, and if we are talking about the system, that means we are talking about this beaker, and rest everything which is outside the beaker will be called as the surrounding. So what is system? System is that part of the universe which is under observation, and the remaining part of the universe is called the surrounding. And universe constitute of our system and the surrounding. However, entire universe other than this system is not affected by the change taking place in the system. Therefore, for the practical purpose, the surrounding is that portion which is remaining universe which can interact with the system. Usually, the region of the space in the neighborhood of the system constitute the surrounding. So, surrounding is the part excluding the system of the universe. Now, how many types of systems are there? There are 3 types of systems. The open system, closed system and isolated system. Open system is that which can exchange matter as well as energy with the surrounding. Like for example, a hot cup of tea kept on the table, it will exchange matter as well as heat, energy. How? See, the water which is present on the uppermost layer of the tea cup will evaporate. That means the matter is exchanged, and when it is evaporating, it is taking energy also with itself. After some time, it will become cool. So, it is exchanging matter as well as energy. Such system is called a open system. Now, coming to the closed system. What is a closed system? A closed system is that like this beaker containing some liquid but is covered from the top. That means it can exchange energy. That means after some time it will become cool, or if it is very cool, it will come to the room temperature. So it is exchanging energy but cannot exchange matter. Why? Because it is covered with a lid. So such a system is called a closed system. Now the third type of system is the isolated system. What is an isolated system? Isolated system is that in which neither matter can be exchanged nor energy can be exchanged. Like for example is a thermos flask. In a thermos flask, if we put cold water, it remains cold. If we put hot water, it remains hot. It can neither exchange energy nor matter with the universe. So, we have 3 types of systems: open system, closed system and isolated system. Now, next is the state of a system. Now, when we are talking about the system, we have to describe the state of the system also. Now, what is meant by the state of the system? See children, in order to make any useful calculation, we need to specify some of the quantities, or you can say the properties of the system, such as pressure, volume, temperature and its composition. If we need to know anything about the system, we should know the pressure, volume, composition and temperature of the system. These functions will describe the state of the system. Now, in thermodynamics, a different and much simpler concept of the state of system is also introduced, and it does not need detailed knowledge of the motion of the particles. Why? Because we deal with the average measurable properties of the system, and we specify the state of the system by using the state function or the state variable. Now, the state of thermodynamic system is described by which all state variables, which are actually the macroscopic or the bulk properties, like your pressure, volume, temperature and the composition. You can say the amount of gas. These are your state variables, or you can say the state function. Now, the internal energy of a system, it changes when two things takes place. First is heat, second is work. Now, what is internal energy? You all know that internal energy of a system is the the change in the internal energy of the system. How it take place? Now, first of all, you should know what is meant by internal energy of a system. See, the internal energy of a system is that energy which is the sum total of all types of energy which the system carries, whether it is due to the position, it is due to the movement of the particle, motion of the particle, or any other type of energy, vibrational energy, rotational energy, whatever energy is possessed by the state of the system, the sum total of all those types of energies is called the internal energy of the system. Now, how does the internal energy of a system changes? It changes either by the heat or by work. Now, how it changes by heat? If heat enters or leaves the system, the internal energy changes. When the heat enters the system, then the internal energy it is denoted by U, and when heat enters the system, the internal energy increases. When heat exits the system, the internal energy decreases. Similar is the case by the work. Now, what is work? If work is done on the system, the internal energy increases. If work is done by the system, the internal energy decreases. Now, how it is done? See. Suppose we are having an adiabatic system which neither permits energy nor matter to come out or go inside. That means the heat change, the Q is equal to 0 here. Q is 0. No change in energy is taking place. Now, if suppose work is done by the system expands, the system is expanding, then it will have to you can say spend some energy, and the spending of energy reduces the internal energy. And if the system contracts, that means if from outside I push it down, that means the system is contracting. From outside we are doing work on the system, it will increase the internal energy. See, the change in the internal energy of the system will be denoted by delta U. U is the sign for internal energy. Change in internal energy is denoted by delta U and will be equal to the internal energy of state B, that is the second state, minus the internal energy of state A, that is the first state. Now, as I have already told you, work done by the system decreases the internal energy. Work done on the system increases the internal energy. Now next is the heat. How heat change the internal energy. See children, suppose we have a system. The system is now having some matter inside it, and the system, it is allowing the heat to transfer through its boundary. It is not an isolated system. The heat can easily enter or exit from the system through the boundaries. When heat is entering the system, that means the internal energy U is increasing. When heat is leaving the system, then the internal energy is decreasing. Now coming to the first law of thermodynamics. What does the first law of thermodynamics states? It states that the energy of an isolated system is constant. That means when a system is isolated, like your thermos flask, its energy is constant. That is according to the law of conservation of energy, that energy can neither be created nor be destroyed. This is your first law of thermodynamics. Now today we'll wind up with this much today. In the next presentation, we'll be studying with the next topic. Till then, you all are requested to kindly go through the first law of thermodynamics, system, surrounding, open and closed system, internal energy and state function through the NCERT book. Thank you. Sai Ram.